Hi everyone, let's talk about Doppler effect in sound waves. First of all, let's try to understand what is Doppler effect. Doppler effect is the apparent change in the frequency of waves due to relative motion between the source of the waves and the observer. There are different scenarios. Let's take up the first scenario when source of the sound wave is moving towards the observer with a velocity vs. In this case, source is actually compressing its own waves, thereby reducing the wavelength and increasing the apparent frequency. Let's try to understand how exactly this happens. The apparent frequency lambda dash is equal to lambda minus Vs into t, where Vs is the velocity of source and t is the time period. So this can be written as Vt minus Vs into t. So therefore apparent frequency f dash would be equal to V upon lambda dash. This would be equal to V upon Vt minus Vs into t. This can be simplified as 1 upon t multiplied by V upon V minus Vs. 1 upon t is the original frequency of sound waves f. V upon V minus Vs. So apparent frequency in the case when source is moving towards the stationary observer is equal to f multiplied by V upon V minus Vs. Let us take up another case when source of the sound is moving away from the stationary observer. In this case, the waves are going to get stretched out, which will increase the wavelength of the waves and decrease the apparent frequency. So let's try to understand how exactly this happens. The apparent wavelength lambda dash will now be equal to lambda plus Vs into t. This can be written as Vt plus Vs into t. Therefore apparent frequency f dash would be equal to V upon lambda dash. This will be equal to V upon Vt plus Vs into t. This can be simplified 1 upon t multiplied by V upon V plus Vs. 1 upon t is equal to original frequency f So in this case, when source is moving away from the stationary observer, apparent frequency f dash is equal to f multiplied by V upon V plus Vs. Let us take up another case when observer is moving towards the stationary source with a velocity v naught. In this case, the velocity of sound with respect to observer will get increased. So v dash would be equal to v plus v naught. So this will reduce the time period of the waves. So new time period would be equal to lambda upon v dash. This would be equal to lambda upon v plus v naught. Lambda can be written as v upon f. Therefore apparent frequency in this case would be equal to 1 upon t dash equal to f v plus v naught upon v. So apparent frequency in the case when observer is moving towards the stationary source with a velocity v naught is equal to f multiplied by v plus v naught upon v. Now let us take up the fourth case when observer is moving away from the stationary source. In this case, velocity of sound with respect to observer is going to get decreased. This will now be equal to v minus v naught. Therefore, time period of the wave will get increased. This would be equal to lambda upon v minus v naught. Lambda can be written as v upon f v minus v naught. Therefore, apparent frequency in this case would be equal to 1 upon t dash equal to f multiplied by v minus v naught upon v. So apparent frequency in the case when observer is moving away from the stationary source is equal to f multiplied by v minus v naught upon v. If we combine all the four cases together, then apparent frequency of the sound waves would be equal to f multiplied by v plus minus v naught upon v minus plus vs. Alright, thank you very much.